Good morning and welcome in the physics session. We are going to study the first lesson of this chapter. The chapter number 12 is about the sound, and you know that the sound is a form of energy, and this energy is transferred in the form of wave. We studied in the previous chapter, and it is a kind of mechanical longitudinal wave. If you forgot, I just want to remind you there were two types of waves. One was called electromagnetic wave, other was mechanical wave. Mechanical wave is a wave that requires medium. Electromagnetic wave is a wave that does not require any medium. So sound is one of the mechanical waveform, and that is longitudinal wave in which particle of medium and the propagation of wave travel along the direction. Either if my sound is moving away from me, so particle of medium may come to me or away from me. But the medium here is the air, and we can observe in different kind of experiments and different kind of we already studied that how sound is traveling, and this sensation of the sound may lead to three possible things that we have to discuss. First of all, how this sound is produced, that is by the vibration in the body. Secondly, how this sound is propagated from one point to another point, that is in the form of longitudinal wave. And third thing is that this sound is heard by the ear or microphone, so how it is being heard and how the sensation of the sound is being observed. So this is all about the sound that we will study in this chapter, and today's topic is characteristic of sound, in which we are going to talk about the it is not the objective is how sound is uh, produced, and how what are the basic characteristics of the sound that we have to discuss. So sound can be produced by a vibration in any object. For example, if I hit something like this, if I hit this one, sound is produced, but its microscopic view tells us that its surface is going to move up and down, and we can easily exhibit the sound or observe the sound because of this vibration. Even I am talking, if my lips are not vibrating, my tongue is not vibrating, the sound or vocal cord is not vibrating, there is no sound produced. So for whenever you beat the drum surface vibrates. So the simple answer, whenever an object vibrates, so the sound is being produced. Okay, I just talk about that we can produce a sound by vibration in a body. Secondly, to transport the sound from one point to another point, we need a medium, because this is a mechanical wave type. We need the medium. We can observe this medium thing. If you remember, we had an experiment, we studied experiment in our previous classes, a bell jar experiment, that there is a bell inside a jar, and it is sounded when it is switched on, we can hear the sound. But after some time, if you evacuate the air from it, so sound becomes feeble, and it decreases until you keep on evacuating the air from the jar, the sound becomes diminished, it becomes abolished, there is no sound after some time. So it means that if air is not there, sound cannot transfer. Even sound cannot transfer through vacuum in the space. The sound need a medium, even though that medium can be air, that medium can be water. For example, if you are swimming inside the water and you just make a vibration, like you hit two stones together inside the water, so you can hear the sound of those stones, and that waves are transported from the liquid. Similarly, wave can transport through air, we can observe it on daily basis. Every time we observe this thing. And there is also, wave can also transport in the medium, like if you are on a rail track and you put your ear on the track, you can easily listen the sound of the train coming to you. Even you can put your ear on the road, and you, if there is no traffic, no car or truck, but if something is coming far from away, but you can exhibit the vibration and you can easily listen the vibration. So sound requires a medium. That's the first thing that we need to understand about the sound wave. So the first thing, sound can travel through any kind of matter, but not through vacuum. As I told you, it cannot be traveled through the vacuum. Similarly, if you struck two stones inside the water, swimmer can easily hear that sound. When you put the ear on the flat against the ground or on the rail track, you can easily uh, hear the sound of the train coming to you, approaching to you. The sound cannot travel in the absence of the matter is just, I'm talking about any kind of material. It can be liquid, solid, gas, whatever it is. So that's why I use the word matter to show all of these three all together. Sound can travel through air, that is Bell jar experiment. Sound can travel through the rail tracks or the road, that is material, solid material. Even sound can also travel in the water. We heard that when two stones are striking together, and if someone is swimming, he can easily hear the sound. And also, if you want to you want to exhibit whenever there is an earthquake, so the sound from the air is heard, and also sound from the earth in the form of tremor we can exhibit. So this is how the sound travels through the medium. But this is very, very important, that the speed of the sound is different in different materials. And it's really interesting fact. Usually we think that sound should be faster in the air than liquid and then solids, but it is opposite. In the solid, sound is much higher. But why it happens? Actually, in solids, molecules are packed. You, all of you are aware about it. You study the chemistry and you are very good in chemistry, I know. So molecules are packed together. When molecules are close together, they just give the energy. Like if you are sitting together, you just push someone that is touching yourself, so you can transfer the energy. But if you are a distance apart, you need to go there first and then transfer energy. So same thing happens with the molecules. When molecules are packed together, they transfer energy within no time. But molecules are away from each other, they need to move there first and then transfer energy. So it's take much time to transfer energy when they are away from each other. That's why sound travels slower in the air as compared to the liquid, as compared to the solid. So solid has the maximum speed of sound. So we can also see this thing in a practical table that you can see on your screen in PowerPoint. It's a table number 12 one. You can see the speed of sound in air is 343 meter per second. It is at 20 degrees Celsius. But at 0 degree it is 331. It means that temperature also affects the speed of sound. In helium it is 1005. But if you go down at the bottom, you can see in concrete it's approximately 3000 meters per second. So in concrete, in aluminium, in glass, you can see in glass, it's the solid that has organized matter, organized atoms. So it has very good speed, almost maximum in iron and aluminum. Aluminum has the maximum speed 5100 meters per second. But you can see its speed is slowest in air as compared to the solid, and the water it is 1440. In hydrogen it is 1300. So we can say that for now onward we have to remember that the speed of sound depends upon the arrangement of the molecules. If molecules are closer together, the speed of sound is faster. If molecules are away from each other, like in gases, the speed of sound is slower. I just told you here in first two points, you can see I just cut it here, that speed of sound in air is 343 at 20 degrees Celsius at 1 atmospheric pressure. We can also say that the speed of sound also depend upon, number one, the material, it's solid, liquid, or gas. Also it depend upon the temperature. If more the temperature, you can see speed is more. If less the temperature, speed is less. For example, at 0 degrees Celsius in the air, speed is 331 meter per second, but at 20 degrees Celsius it becomes 343 meter per second. Speed increases by 0.6 meter per second if you increase 1 Celsius temperature. At 1 degree Celsius, it will be 331.6. So each 1 degree rise in temperature increases the speed 0.6 meter per second. If temperature raises to 2 degree, so it will become 332.2. So each 1 degree rise in temperature, there is an increase of 0.6 meter per second in each Celsius degree rise. V is equal to 331 plus 0.6. When temperature increases by 10 degrees Celsius. So what will happen? This will become V at 10 degrees Celsius equal to 331 plus 0.6 times 10. How much it will become? 331 plus 6, 337. Similarly, if you use this formula, when temperature rises to 20 degrees Celsius, it becomes 331 plus 0.6 times 20. So 0.6 times 20 is 12. So it will be 343 meter per second. As a rule of thumb, that tells us how close lightning has struck is 1 mile for every 5 seconds before the thunder is heard. So it will take 5 second delay for 1 mile distance. For example, 1 mile, 1609 kilometers, and speed of the sound in air is usually taken. We take it 340 meter per second in a general, for general opinion. Usually it is 331 in meter per second for 0 degree, 343 at 20. But as a general opinion, whenever it will be said, speed of sound is 340 meter per second. So the speed of sound is 340 meter per second. So what will happen after 5 seconds? If you talk about 5 seconds, you multiply by 340 with the 5. So what will happen? 340 times 5, it is almost 1600 kilometers. So it becomes 1600 kilometer. But in another way, if you want 340 meter in 1 second, the speed of sound is, so we can say it is approximately 5 seconds it will take. So this is just how much time it will take to cover a distance of 1 mile. So it will take 5 seconds to cover a distance of 1 mile. Now we are going to talk about further characteristics of the sound, and the property which I am going to discuss is the loudness. In simple language, the loud mean how much high the amplitude is, how much noisy the sound is, you can say. So you the best word you use is intense. So what is actually the intensity? How many sound waves are passing through a unit area? Like in simple sense, how much is the crowding of wave at a point? If more waves are passing through an area, it is more intense. If less number of waves are passing through an area, it's less intense. So you can also say energy per unit area is called intensity. For example, if this is an area, and through this area, if 10 waves of sound are passing, it's less intense as compared to 10,000 number of waves are passing. So more the waves passing through the area, it is more intensity, more crowding. So if more the intensity, the sound will be the louder. So the characteristic that I am talking about, it is the intensity of the sound. Sorry, it is the loudness of the sound. It depends upon the intensity of the sound, that how much crowding of the waves is at a particular point. If more the intensity, more the loudness. And there is one more thing that also affect the loudness of the sound, that is amplitude of vibration. If something is vibrating with more amplitude, so it will be more louder sound, because energy per unit area will increase in this sense. So energy per unit area, when it is increases, it means intensity increases, either because of the crowding of the wave, either because of the you call amplitude of vibration. So whenever intensity of the sound increases, we can say the sound is more loud. So here it is related to the intensity of the sound. For example, I just wrote here the definition of the intensity: energy per unit time crossing through a unit area, and unit of the intensity is watt per square meter. So you can use W as a watt, and meter square is per meter square is the area. The second characteristic that I want to talk is the pitch. We say that how much shrill and how much grave the sound is. Now the meaning of shrill and grave mean, shrill sound is like the sound of the children or the ladies, and the grave sound is like the gentleman or the man sound. For example, if you are talking about my sound, it's a little bit grave. but if you will talk about some lady sound, so it will be shrill. So whenever a sound is shrill, we say that it is having high pitch. Shrill mean high pitch and more the frequency, and the grave mean low pitch, less the frequency. So the sound quality, a sound characteristic that is used to differentiate between shrill and grave sound. For example, you have this drum here, this brass drum. The sound of the brass drum is dum dum dum. It's a grave sound. But when you are talking about the sound of piccolo or violin, it's like ee, ee, just irritates you. Yes, the sound of the children, or when they are making crying or something, or the ladies talking, sometimes you irritate because of their sound pitch. The frequency is high, so it becomes like this. Frequency is how many vibrations per second. So, whenever you are listening the music and you just make the track FF mode, fast forward mode, what will happen? What
His
will
voice
happen to the
becomes
track?
like a chipmunk.
Yeah, it
Yes.
becomes high pitched.
Yes, it will be like
Yes.
why? Why this sound is shrill now? Because you increase the
And
Frequency.
pitch. Frequency.
frequency, number of vibration per second, you increased it. Because fast forward mean more number of waves in the same second or same time. So you increase the frequency. Similarly, if you are listening a female voice, you love any female singer, so if you slow it down, so when you want to listen in slow mo, what will happen to the sound of that female? Whoa. What is happening? Why it is grave now? Because you reduce the frequency. So this is the same thing, that whenever a man who has a grave sound, who has more frequency of the sound, if he starts speaking faster, so his sound will become shrill. That's why some people, some male has a female voice, and some females, because of their frequency is less, so they have a grave sound. So this pitch is really interesting to understand. But what is the point of remembering that whenever we talk about the characteristic of sound called pitch, we will say that it is the characteristic that is used to differentiate the sound of shrill and grave sound. Why this is a shrill sound and a grave sound? Because shrill sound has a more frequency, grave sound has a less frequency. So the property which creates shrill and grave sound is called frequency. So because of the frequency change, the sound becomes lower the frequency, lower the pitch, higher the frequency, higher the pitch. But I forget to write here one more word with both of these sentences: lower the frequency, lower the pitch, and grave sound; higher the frequency, higher the pitch, and shrill sound. You got it now?
I have a
So
question.
this is how the sound is being changed. Now, but we can only hear the sound in between 20 hertz to 20,000 hertz, depending upon the health of the ear. If my ear is perfect, it's working perfectly, then I can be able to hear the sound from 20 hertz to 20,000 hertz for a perfect ear, normal healthy ear. So this range that we can hear from this normal or healthy ear is called audible frequency range. What we call it? Audible frequency range. So this audible frequency range for a normal ear is 20 hertz to 20,000 hertz. The sound below 20 hertz are inaudible for us. More than 20,000 hertz have more frequency, and it's the sound becomes too much shrill that we still are not able to listen that sound. So the human range that a human ear can hear the sound is called audible range, from 20 hertz to 20,000 hertz. But this audible frequency range still changes with the health of the ear and also with the age. The old people are not able, like me, I'm old one, that's why I was not able to hear about 15,000 hertz. So some people which are much older, they will not be able to hear the sound which has a frequency more than 10,000 hertz. So this is the audible range that is affected by the age and health of the ear. But for the normal healthy ear, audible frequency range of the sound is 20 to 20,000 hertz. Now, the sound which is more than 20,000 hertz, we call them ultrasounds. Dogs can hear the sound more than 20,000 hertz up to 50,000 hertz. So, the dog trainer usually use a whistle. We call it a silent whistle. We blow that whistle, but we will not be able to hear that whistle. But the dogs can hear, and they can come to you, and they can perform their activities. So the silent whistle is silent for us, but the dogs can hear it, and we call the dogs according to that one. Also, there are some animals which has frequency like 100,000 hertz, like bat can detect the frequency of sound of 100,000 hertz. Also, dolphins has the ability to hear the ultrasound is 100,000 hertz. These ultrasounds are also used for many medical purposes, like the ultrasounds can also be used to know the abnormalities of the body's different ailments. Also, these are used to detect the kidney stone. These are used to detect the baby in the womb is a male or a female. Are also used to remove the plaque from the teeth, the yellowish plaque from the teeth. These are also used to know the cracks and the depth of the sea. So these ultrasounds are usually used for many purposes. But the sound less than 20 hertz is called infrasonic, and infrasounds or infrasonics are still not able to heard by us, and we are not able to hear it. So these source of the infrasonic wave include earthquake, thunder, volcanoes, and a wave produced by vibrating heavy machinery. Focusing camera actually sends ultrasonic pulse. These solid lines are the ultrasonic that are going and hitting the person to whom the picture is to be taken, and these dashed line are the rebounding waves. So the time within which these waves go and get back, this lens of the camera adjusts itself to take the picture. As this ultrasound wave goes, hits the person and then get back, it is the same process of radar function. When radar sound sends the waves, and waves strike to the object and get back, so they can detect how much distance of the plane or the object is from radar. Similarly, bats use this work. Bats send a signal in the form of ultrasonic wave. If that signal hits with something and get back to them, so they just detect the distance in their brain. So they calculate the distance and they change their path, that there is some hurdle, some barrier coming in front of them. So the same way autofocusing camera is working. So now the question is, we are going to use autofocusing camera, and autofocusing cameras emit a pulse of very high frequency that are ultrasound or ultrasonic, that travel to the object being photographed, and include a sensor that detects the returning reflecting sound as shown in the figure 12.1. To get an idea of the time sensitivity of the detector, calculate the travel time of the pulse for the object which is 1 meter away. So how to find the travel time? You need to find the time. This is the simple, you can say, uh, simple uh, equation of motion, that is speed is equal to distance over time. So if you need to find time, so it is distance over speed. But the problem is, you have been given by the distance. What is the speed? Can anybody tell me what is the speed of this wave?
343.
343, but I told you yesterday generally we take it 340. Okay, why we are using this one? Because the sound that is being the sound wave that is sent by this autofocusing camera is ultrasonic. Ultrasonic is a sound wave, and speed of sound wave is understood, it's 340 meters. So what you will do to find the time? The formula is time is equal to distance over speed, and here you use 2 meter and 340 meter per second or 343 meter per second. So it is how much?
5.8.
We convert it into millisecond. Okay, this is for one. What about the 20-meter away? If the person is 20-meter away, how will you find it?
It will
40 divide 340.
distance will be 40.
It will be 0.1117.
Yeah.
Yeah, distance is 40 divided by 340, so it's almost 120 milliseconds or 0.12 seconds. I told you the sound wave, how the sound wave travel in a medium. If you didn't forget, I just told you that whenever sound wave travel in a medium, they show a vibration of molecule in the medium. If you see, these are the molecules that are closer to the drum membrane. So these molecules are close to each other, so there will be more pressure. So we can also say that these waves are longitudinal waves, but we can also name them pressure waves. So here pressure is more, pressure is less, pressure is more, pressure is less. So in every compression, pressure is high, every rarefaction, pressure is low. So these are longitudinal waves. We also name them pressure waves, which travel in the form of compression and expansion or rarefaction. To understand this idea of pressure, let us see this figure that I want to show you here. This is the wave form of the displacement and the pressure. Whenever the pressure is maximum or minimum, this is the maximum pressure, and that is compression. This is compression, this is compression. At that time, the displacement between the molecules is zero. That molecules are very close to each other, as you can see in the picture. When molecules are very close to each other, you can say the displacement between the molecules is zero. So in the waveform, we can say more the pressure, displacement is less, but less the pressure in the rarefaction, so molecules are distance apart. You can see in this wave that when the pressure is almost zero here, the waves are having distance of plus 0.005. Similarly, when they are at the other end, they are away from each other, so you can say distance is still more. So when the pressure is high, the molecules don't have any distance between them. When pressure is low, they have very high distance. So this can also be seen from this picture, that more the pressure, molecules are close, less the pressure, molecules are away from each other. So this was all about sound and its basic characteristics. Hopefully it's easy topic for you guys.